Hi everyone! Ever wondered how some graphics on the web stay perfectly sharp no matter how much you zoom in? Or how icons change color instantly? Chances are you have encountered SVG, Scalable Vector Graphics. Today we'll dive into what SVG is, why it's awesome, how to use it, draw basic shapes, make it accessible, and even add a little sparkle with animations. Let's get started. So what's the big deal? SVG stands for Scalable Vector Graphics. Think of it like this. HTML uses text to structure text and content. SVG uses text to structure drawings. It's based on XML, which looks similar to HTML. Instead of defining images pixel by pixel like JPEGs or PNGs, SVG describes shapes mathematically. Draw a cycle. Here, draw a line from this point to that point. The magic word is scalable. You can resize an SVG image to be tiny or billboard sized, and it will always look perfectly crisp. No pixelation. Plus, because it's just text code, we can easily style it with CSS and interact with it using JavaScript. It's a proper web standard supported by all modern browsers. Okay, sounds cool, but why should we actually use it? First, scalability is a king. Perfect sharpness on all devices, big or small. Future-proof. Often, SVG files are smaller than PNGs or GIFs for the same graphic, saving bandwidth and loading time. Styling with CSS is a huge win. Need to change the color of all icons for dark mode? Easy. It integrates perfectly with JavaScript. You can make interactive graphics or data visualizations. Being text-based make it accessible. Screen readers can announce what the graphic represents. Search engines can potentially index within SVGs. And if you put the SVG code directly into your HTML Inline SVG, the browser does not need to fetch a separate file, which can speed things up slightly. Let's be fair, SVG is not a silver bullet for everything. If you have an incredibly complex SVG with thousands of points and shapes, the browser might struggle to render it smoothly, especially during animations. Performance can become an issue. It's absolutely terrible for photographs. Vector graphics just can't represent that level of detail efficiently. Stick to raster formats like JPEG or WebP for photos. And while browser support is fantastic now, if you really need to support dinosaurs like Internet Explorer 8, well, first my condolences, and second, you need image fallbacks. But honestly, this is really a concern today. The key takeaway is choose the right format for the content. Logos, icons, charts, SVG, photos, JPEG or WebP. Alright, how do we actually get SVG onto our web page? There are four main ways. First, inline SVG. You literally copy the SVG code and paste it right into your HTML file. This is often the best method if you want to style internal parts of the SVG with CSS or manipulate it with JavaScript, because SVG becomes part of the page structure. Second, the good old image tag. Just point the source attribute to SVG file. Super simple, works like any other image. The downside, you can easily style the inside of the SVG tag using CSS from your main style sheet. It's treated like a black box. Third, the object tag. This is a bit more versatile than image. It allows for fallbacks, showing a PNG if SVG is not supported, and can allow some interaction with JavaScript, so it is not often more complex than Inline SVG. And fourth, CSS backgrounds. You can use an SVG file in your CSS background image property, just like a PNG or JPEG. Great for repeating patterns or simple decorative icons. For today's demo, focusing on shapes and animation, Inline SVG gives us the most power. Now, how do we actually position things? SVG uses a coordinate grid. Crucially, unlike useful mass graphs, the starting point 0, 0 is in the top left corner. X increases to the right as expected by Y increases downwards. This trips up beginners sometimes. The viewBox attribute is super important. It defines the fundamental coordinate space of your drawing. All coordinates inside the SVG will be relative to this box. The width and height attributes of the main SVG tag then tell the browser how big to actually display this viewBox on the page. In this example, we define a 100x100 internal space viewBox, but tell the browser to render it at 250 pixels wide and 250 pixels high. The browser automatically scales the content defined in the viewBox to fit. The blue rectangle fills the entire viewBox and the red circle is centered with it. The green dot is at 1730 within the viewBox coordinate system. Alright, let's get to the fun part. Drawing. SVG provides specific tags for creating basic geometrical shapes. We'll look at the most common ones now. I've put each shape on some slide, so let's begin. First up, the humble rectangle. Using the rect tag, you define its position with X and Y for the top left corner coordinates. Width and height set its dimensions. Simple enough. Fill the interior color. Stroke the outline color. And stroke width is how thick the outline is. Bonus, you can make rounded corners using Rx, horizontal radius, and Ry, vertical radius. If you only specify Rx, Ry defaults to the same value. Here we have an orange rectangle with a black border and a smaller semi-transparent white one with rounded corners inside. Next, the circle. Using circle. This one is defined by its center point and radius. Cx and Cy specify the coordinates of the circle's center. Remember, 0, 0 is top left. R specifies the radius. Again, you can use fill, stroke, stroke width, etc. Here is the red circle with a white outline and a smaller with white. Similar to a circle but potentially squashed or stretched is the ellipse. It also uses Cx and Cy for the center point, but instead of a single radius, it has Rx for the horizontal radius and Ry for the vertical radius. If Rx and Ry are equal, you get a perfect circle. Here we have a white-purple ellipse and a tall, thin whitish one. Need a straight line? Use line tag. This is defined simply by its start point and end point. Note that lines don't have a fill property, only stroke properties. You can also create dashed lines using the stroke-array attribute. You provide a list of numbers representing the length of dashes and gaps. 5 and 3 means a 5-unit dash followed by a 3-unit gap, repeated along the line. Here a solid green line and a dashed cyan line. What if you need multiple connected lines, like a zigzag? Use tag polyline. It takes a points attribute containing a list of XY coordinates separated by spaces or commas. The browser draws straight lines connecting these points in order. Crucially, polyline is an open shape by default. It does not automatically connect the last point to the first. Because of this, you usually set fill equals none unless you want some weird fill effects. This example draws a simple zigzag line. Similar to polyline, tag polygon also takes a list of points. The key difference: polygon automatically draws a straight line from the last point back to the first point, creating a closed shape. This means polygons usually have a fill color, as they represent a filled area. Here the first example creates a triangle. Second, use small points to create a simple star shape. Now, beyond the basic shapes, there is the mighty path element. This is the most powerful and flexible drawing tool in SVG. You can create literally any 2D shape with paths, including straight lines, complete curves, arcs, and combination of this. It works using a special mini language inside the D attribute, which stands for data. You use commands like M, move to a straight point without drawing, L, draw a straight line to, Q, draw a quadratic Bezier curve, C, cubic Bezier, A, elliptical arc, and Z, close the path by drawing a line back to the start. Uppercase commands use absolute coordinates, lowercase use relative coordinates. Learning path. Data takes practice, but it unlocks incredible possibilities. Many design tools export graphics as SVG paths. Here we draw a simple triangle using move and line commands, and a curved line using a quadratic Bezier command. Use the G tag to group SVG element. This lets you apply styles like fill or transforms to the whole group at once. It also helps organize your code. The example shows one group inheriting styles and another group being moved and rotated together. The transform attribute applies geometric transformations. Translate to move, scale to resize, rotate to rotate around the point, and skew to slant. You can change them, but order matters. The example shows these functions. Key point: remember to set the rotation center if needed. Okay, we have drawn cool stuff, but is it understandable for everyone? Accessibility is super important on the web. People using screen readers or other assertive technologies need to know what our graphics represent. Luckily, because SVG is just text or code, we can add information directly into it. The two key tags for this are title and desc description. Let's look at how to use them. Inside your SVG tag, you should add title and optionally desc elements right at the beginning. The title should provide a concise, descriptive name for the SVG, similar to the alt text on the image tag. The desc description calls for a more detailed explanation if the graphic is complex, like a chart or diagram. It's best practice to give these elements ID attributes, and then reference these IDs in an area labeled by attribute on the main SVG tag. Also add role image to the SVG tag to explicitly tell assistive technologies that this is an image. This way, a screen reader will announce the title and description, making the content accessible. For purely decorative SVGs, you might omit title or desk and use area hidden true. Icons are a very common use case for SVGs. How do we make them accessible? For meaningful icons, use title and role image. For decorative icons, use area hidden true. For icon only, button or link, use icon area hidden, but button or link needs area label. For icons with text, use icon, usually area hidden, and text provides context, and always test. Static graphics are cool, but animated graphics even cooler. And yes, SVG is highly animatable. Three main ways are CSS, use familiar keyframes and transitions, often simplest and performant. The second one is SMIL, native SVG text like animate, self-contained, powerful, but verbose. And JavaScript, ultimate control, especially with libraries, GSAP, Snap SVG, etc. Best for complex interactions. Use CSS transition for simple interactions, like hover effects, use keyframes and animation properly for more complex looping animations. Example shows both hover transition and a keyframe transition, pulsing color and scale. SMIL uses text like animate inside the SVG. Key attributes, attribute name, values, dur, repeat counts. Pros, self-contained. Cons, clunky syntax, harder debugging than CSS. Example shows animating fill on a rectangle and position on a circle. JavaScript offers the most control, perfect for interactivity, physics, or complex sequences. Vanilla.js is possible but often complex. Libraries such as GSAP, Snap SVG, SVG.js, and D3.js are highly recommended to simplify animation tasks. So let's quickly recap the superpowers SVG gives us. It delivers perfectly sharp graphics no matter the screen size or zoom level because it's vector-based. It plays incredibly well with other web technologies like CSS for styling and JavaScript for interactivity and complex animations. We can and should make our SVGs accessible using title and description elements. We can bring them to life with various animations techniques. It's the perfect tool for so many common web graphics needs: logos, icons, illustrations, data visualizations, and more. Hopefully you now have a better understanding of what SVG is and why it's such a valuable part of the modern web development toolkit. This brings me to the end of my presentation. Thank you all for listening. I hope this overview has sparked your interest in using SVG more in your projects.